Welcome back, NNC viewers. Today we're going to interview the masterminds behind the people who are building a mall on Mars. Let's go. So today we're going to interview the CEO of this company who came up with this genius idea. Let's go. Excuse me, ma'am.
What?
Okay, so what are you going to do about the temperature on Mars?
So what we're doing with the temperature sensor on Mars is basically we're going to be measuring the temperature in the store. There's not just one store in the mall, like there's so many. So we have to make sure that it's perfect for each individual customer and it's not too hot and not too cold for an uncomfortable shopping trip on Mars. So that's what we're going to do with the temperature sensor.
You heard that right, fellow watchers. Next up, we're going to interview another employee at the company. Let's go. So me and the viewers want to know, why are you doing this?
Well, obviously, the climate on Mars is very different to the one on Earth. You know, temperatures can range from the 60s or 70s during the day, or like on the ground, to negative 225 degrees Fahrenheit at night. So if we're going to be constructing a building as large as the one we're going to, you know, it's going to have dozens of shops, dozens of restaurants. It's important that the customers walking around are not uncomfortable. They do not have any sort of, they're not needing to like layer up or take off clothes. And then on top of that, we don't want, you know, our food to go bad. We don't want our burgers to mold or anything.
Yeah.
So it's very important that we implement these in order to, so yeah, that's why we're gonna do it.
Okay. You heard that. Lastly, we're going to ask another employee about one more question. Okay, my viewers and I want to know, how are you going to do this?
Okay, so basically we have a special temperature sensor that our CTO designed himself, and we are going to place it in like food areas and stores and just other areas. And what the sensors are going to do is it doesn't require a person to be standing there at all times, but pretty neat, right? Mm-hmm. But it's going to send information to a computer that we can always check, and the computer is going to give us notifications when things are wrong. Go.
So I'm thinking for the temperature sensor, we should use an analog version.
I don't agree with that. I think we should use digital because it's going to be less harder and less inexpensive too.
Actually,
Room's getting heated.
okay, so actually the analog is cheaper and it has a large range for the temperatures on
Okay,
Mars.
whatever. We should call Danny. We'll get Danny's opinion.
Okay.
Hey guys, what's up? Okay, so basically in the Arduino, you see this little this USB right here that has all the code. So all this code is going to be telling the Arduino what to do. We decided to use the Uno, the digital one, so that it connects into the bread box and to the digital sensor. And if we simulate it, you can see that it displays the temperature in Fahrenheit. Currently it's 76.47, and we use this temperature sensor right here to read those, and the potentiometer to basically help to display what's going on. Then over on this side you have the resistor that's basically kind of facilitating the entire like current and making sure that everything's working. You plug all this back into the terminals on the Arduino, and it helps to just display the entire thing that's going on. So looking at the code, you see all the things that include what's that. Basically what's that doing is telling what's it's giving the code to, what has to happen, and it gives the LCD the display right here. Then you take the sensor input, define it as an integer, float as the temperature so that we can have the decimal temperature just to make it more exact, right? And you basically just get your entire setup defined, and you initialize the LCD so that it turns on so you can actually see what's going on. And you measure your temperature we're using, and then display it so that you can see on this display. And then for the measure, what we need to do is take it from the float, turn it into the fraction, the actual temperature, convert the voltage into Celsius, and then back to Fahrenheit, just so that it displays in a way that us Americans can read.
So like, why are we even doing analog? Like, what's better about it?
Wait, let me go get Isabella really quick.
Okay. Hey guys.
Hey, things all here.
Okay, so I'm thinking we should use analog because it's cheap, it has a large range because, you know, Mars can be really hot or really cold, and it also is like really fast responding, so like we can get like the temperatures quickly.
But analog also does really heat up like super fast, so that could be also a con.
Yeah, but like at the same time, digital is really expensive. So do we really want to spend more money on the sensors, or do we want to spend it more on the mall?
Okay, well, what if we use LED sensors? Because they don't heat up, they're easy to use, and I think our CTO could work with them.
And they're really environmentally friendly.
Yeah.
Okay.
Let's go.
Hey guys, as CEO, I think we should get this meeting started, and I'm telling you to get this meeting started. So basically, I think originally we should have used analog because it would have been a lot better and a lot easier and probably more costly effective. But then I did some research on digital and realized that was actually going to be less inexpensive in the long run. And I learned that some of the pros about digital were better accuracy, immunity of electrical noise, and that led to more reliable data. So I think actually we should do digital.
I was researching the types of sensors we can use for a temperature sensor, and I believe that we should use an analog sensor because it's cheaper compared to most sensors. It can detect wide ranges of temperatures, which Mars has a thin atmosphere, so we'll really need that. And it's quick responding, so we can get alerted quickly whenever something odd happens. It was really difficult to get Addie and the rest of the crew to hop on my idea because stuff like it heating up quickly, so it'll be inaccurate. It was like really irritating until Isabella suggested the idea of using LEDs. And I honestly learned that it was a lot better because it's environmentally safe, so it wouldn't impact our ecosystem as much, and it was cheap like an analog sensor.
Hi guys. So one major difficulty I faced was kind of getting the team to agree on what sensor to use, because Tina and Addie both wanted different sensors and nobody was really coming to a consensus of digital or analog. So I did some research and I suggested that we use LED sensors because they're easy to use, they're budget friendly. And something that I learned is when I did some research, I found that LED sensors would be the best for our team's temperature sensor because it was the best fit and the pros outweighed the cons.
One difficulty I faced throughout this project was trying to find environmentally safe and sustainable components to use in our sensors. It was really hard to land on one. Everything had its pros and its cons. But eventually I solved this by collaborating with my team. I worked with Isabella, and we landed on LED lights for several reasons, and I actually learned a lot about them as well. I learned how long-lasting they are. I learned how easy and cheap they are to produce. I learned about their reliability and just how insanely energy efficient they are. And I feel like this project as a whole has really taught me a lot about teamwork and what it means to have a good work ethic when you're surrounded by other people with expectations to meet.
Yeah. Well put, George. That's great to hear. Glad to hear you got everything sorted out. Basically, some problems that I ran into, obviously, as a team, we were having some trouble picking which design, which sensor we should be using, but we got that all figured out. We used the temperature sensor since it's a good thing to build off of, and the Arduino design that we picked using the LED screen. Some other problems that I had were with the code and the coding aspect of it, making sure everything was running smoothly. All I needed to do to fix that, I did debugging through each line, made sure all the values were previously stated so that there was no syntax errors or the continuity or anything like that. And I just went through each line to make sure everything was right and ended up working out, found my problems. It was awesome. And then also some things just with what screens we should be using to display our things for a prototype that we will implement into the mall using that digital screen with the LEDs that'll show the temperature. We decided to go with Fahrenheit, of course, so that everyone that we need, that's working with us, would be able to read it. And obviously we can show Fahrenheit, Celsius, doesn't matter, that's later stuff. But yeah, it worked out like that, and we got all those problems figured out. We learned a couple new things on what sensors, how to build the actual sensors and Arduinos for it, or for the prototypes that will be and then the actual models that we're using in the mall. So I'm glad we figured all that out, learned a bunch, and yeah. Well, I think that pretty much wraps up this meeting. Thank you so much, guys. It was great to hear each and every one of you. I'm glad we all got all our problems figured out, and I think that's about it.